Next we'll study about the derivation. Okay, this one is for the non-inverting. I'll tell you the derivation also. Next we'll do with the wait. Next we'll do with the derivation of inverting amplifier. Okay. So as in the case of inverting amplifier, as you know, we'll connect the voltage with the negative terminal or with the positive terminal. Negative. So I am connecting the resistance also R1 with a negative terminal, and there is a feedback resistance also. Feedback resistance is always connected with the negative terminal only, and feedback resistance means which output is connected with the input. Okay. Output voltage is denoted by V naught, and this positive one is the grounded, and here we'll provide the voltage, that is plus minus V in, that is the input voltage, and another terminal of the input voltage would be grounded. Okay, got it? Clear? So in this case, let us consider here the current I1 is flowing and here the current I2 is flowing. Okay, so if I'll apply the Kirchhoff current law here, KCL, can I say that I1 is equal to I2? See, what is we'll use in the op-amp, one thing we'll more use in the op-amp, that is the concept of virtual ground. Okay, what is exactly the virtual ground? In the virtual ground, we'll use the concept that suppose here here, as you can see, it is grounded, right? Here it is grounded, then in that case, at this particular instant, the voltage is how much? The voltage is, tell me, at this particular point, the voltage is always 0. So if at this particular point the voltage is 0, due to this virtual ground concept, here also the voltage will be 0. That will write down directly as a virtual ground concept. You can mark it here, that is virtual ground concept. Okay, see, I'll exactly tell you what is exactly the virtual ground concept. Like suppose, as I told you, this is the amplifier. Here it is connected with the positive terminal. Suppose this one is grounded at this particular point. Okay, at this particular point, suppose it is V2 and I am connected with the resistance R in. So at this particular point, by the concept of virtual ground, I am saying that this particular point also would be 0. Suppose at this point V1. So can I say that voltage gain is how much? That is output voltage divided by the difference in the voltage, right? So can I write down VID is equal to V naught divided by A? And if there is an ideal op-amp, then in that case A would be equal to infinity. If A would be equal to infinity, then the difference in the two voltage would be equal to 0, right? If the difference in the two voltage would be equal to 0, so can I say that V1 minus V2 is equal to 0? If V1 minus V2 is equal to 0, can I say that V1 is equal to V2? So we, according to the concept of virtual ground, we get if at this point the voltage is 0, and then at this point also the voltage must be 0 only. Okay, this is the like derivation. You don't need to do this derivation, I just told you to explain it. But in the virtual ground concept, what you need to remember, if at this point the voltage is same, at this point also the voltage is same. So at this point voltage is 0, so at this point also the voltage would be 0. Got it? Now see I1. As you know that I1 is moving from V into 0 or 0 to V in? Tell me. Yes, so if I'll apply nodal analysis, as you know, as you have done earlier, according to the nodal analysis, I1 is moving from V into 0. So can I write down V in minus 0 divided by R1? Similarly, can I write down I2 is moving from 0 to V0 or V0 to 0? See the direction of current? No, see the direction of current. I2 is moving from 0 to V naught. So can I write down 0 minus V naught but divided by RF? Right? So I just want to calculate the voltage gain. So if I want to calculate the voltage gain, can I write this equation as V in by R1 is equal to minus V naught by RF? Can I write it down like this? Now see, I just want to calculate the voltage gain, and you know the voltage gain is represented by AV. A is for the gain, and if I'll calculate the voltage gain, then it would be AV, and voltage gain would be output voltage divided by the input voltage, right? So from this conclusion, if I'll calculate V naught by V in, how much it is? V naught by V in. Can I write down minus RF by R1? I just simply interchange this, right? So what we got as an answer, V naught by V in is how much? Minus RF by R1. So if I want to calculate the V naught output voltage, how much it is? V in multiplied by minus, or we can say minus RF divided by R1. So this is the final output for the output voltage. That is, see, as you can see, I have connected to the negative terminal. Sorry, I have connected to the negative terminal, right? So that's why its output is negative. So that's why if I'll give in this phase, the output will be in the opposite phase. Okay, and how much it is amplified, that depends on the value of RF and R1. Got it?